Hi friends, welcome to the second video on random process. In this video, we will see a problem which defines a characteristic function and say how the process can be a WSS process. We'll move on to the problem. Given a random variable y with characteristic function phi of omega equal to e expected value of e power I omega t, which can be defined as cos omega t plus I sin omega t, and we have a random process defined by x of t where x of t is cos of lambda t plus y. We'll have to show that x of t is a WSS if phi of 1 equal to phi of 2 equal to 0. First and foremost, we'll have to keep in mind what is the end target. The end target is nothing but to show that it is going to be a WSS. We know that there are going to be two conditions to be satisfied for a wide sense stationary process. We will try to recollect them quickly. The first condition being the mean of the random process must be a constant. And the second condition is that the autocorrelation function R of T1, T2, which is defined as expected value of x of T1 product x of T2, must be a function of tau. If these two conditions are satisfied, then we can call the random process to be a WSS process. Now, to satisfy these two quantities, we have been given two criteria, phi of 1 equal to 0 and phi of 2 equal to 0. Now, we will see what is meant by this phi of 1 equal to 0 and phi of 2 equal to 0. What is our phi of omega? My phi of omega is expected value of cos omega t plus I sin omega t. So, what will be phi of 1? Wherever we have omega, replace it with 1. So this becomes expected value of cos t plus I sin t. And what is going to be phi of 2? This will be expected value of cos 2t plus I sin 2t. Now they have said that phi of 1 equal to 0, which means expected value of cos t plus I sin t equal to 0. This being a complex number, I can rewrite this as 0 plus I0. Equating the real parts, we have expected value of cos t to be equal to 0 when I equate the real part. And when I equate the imaginary part, what do I have? I have expected value of sin t to also be equal to 0. So I can take this to be condition number A and condition number B for solving this problem. What is the second criteria we have is phi of 2 equal to 0. This implies expected value of cos 2t plus I sin 2t equal to 0 plus I0 or 0, which has been given to us as condition here. So this implies equating the real part, expected value of cos 2t is 0. So let me mark it as condition number C. And equating the imaginary part, what do we have? Expected value of sin 2t equal to 0. So making use of these four conditions A, B, C and D, we are going to show that this process x of t is going to be a WSS. That is, we are going to show that it is a constant, mean is a constant, and we are going to show that the autocorrelation is going to be a function of tau. What is our x of t, the random process? Cos lambda t plus y. We'll quickly move on to our condition number 1. So for proving our condition number 1, we have to show that e of x of t is going to be a constant. So it is expected value of, what is our x of t? Our x of t is going to be equal to, our x of t is going to be equal to cos of lambda t plus y. So cos of lambda t plus y. So now let me expand this using the formula cos A plus B, which gives me cos A cos B plus sin A sin B. So by the trigonometric identity, cos A plus B is cos A cos B minus sin A sin B, we apply it to the above quantity. So we have expected value of the expansion of it, cos, this is going to be my A, this is going to be my B. So it is cos lambda t, cos B is my y minus sine lambda t and sine y. Now, I need to keep in mind whenever we have expected value to be taken for ax, a being a constant and x being the random variable, we push the constant outside, applying the expectation to just my random variable x. Now, for me in this question, which is my random variable? My random variable is y. So, the expectation will be considered only for the term that involves y and not the other term. In which case, over here, this cos lambda t over here will be treated like a constant like this a. Hence, what we have is this cos lambda t will be pushed outside since it is a constant, applying the expectation to just my cos y. In a similar fashion, sin y is my variable. So this cos lambda t is a constant. So sin lambda t comes outside, applying the expectation to just my sin y. Now, what do I know from my condition number 1? A tells cos lambda t of expected value of cos t is 0. B says expected value of sin t is 0. So in which case expected value of cos y turns out to be 0. Expected value of sin y turns out to be 0. So in this case we have the value of e of x of t to be 0. So what we have proved over here? We have proved that the mean is going to be a constant. So our first condition has been verified. Let us move on to the second condition. What is the second condition? The second condition says that the autocorrelation Rxx of t1, t2 must be a function of tau. What is this tau? Tau is nothing but time 1 difference time 2. Hence, I have to have the final answer as to be a function of time 1 difference time 2. How can I define this autocorrelation? It is defined as the expected value of the product of the two members x of t1 and x of t2. What is our x of t? Our x of t is cos lambda t plus y. So, what will be x of t1 in this case? Wherever I have t, replace with the t1. So, this becomes cos lambda t1 plus y. And what will be x of t2? Wherever I have t, replace it with t2. So, you will have cos lambda t2 plus y. Now, this becomes expected value of cos lambda t1 plus y product cos lambda t2 plus y. Now, we have it of the format cos A, cos B. So now we will try to recollect the trigonometry identity equivalent to it. So we have the trigonometric identity cos A cos B equals cos A plus B plus cos A minus B divided by 2. Now which will be termed as my A over here? This is termed as my A and here this is termed as my B. Now let us try to apply it. So it becomes cos lambda t1 plus y plus lambda t2 plus y. So this is my cos A plus B plus cos, what will be A minus B? Lambda t1 plus y minus lambda t2 minus y. Okay, so this becomes my cos A minus B and everything over here is divided by 2 and we take expected value of this expression. Now moving on, what we know about the expected value of your half? This is going to be constant, so this half comes outside. Let me split it into two terms. Expected value of lambda times cos lambda times, let me combine these two factors, t1 plus t2 plus over here a y, over here a y, a 2y. So this is my first term plus half into expected value of plus y minus y cancels off, leaving you with cos lambda of t1 minus t2. So this becomes my second term. Now let me analyze the two terms separately. First starting with my first term. This is again of the format cos A plus B. Cos A plus B. What we have already seen about cos A plus B? We know that cos A plus B is cos A cos B minus sin A sin B. So now let us apply this expression to our given quantity. What will happen over here? Here we have half expected value of cos lambda T1 plus T2 plus 2y. This is my cos A plus B. Cos A cos B minus sin A sin B. So we have this as half expected value of cos lambda T1 plus T2 cos A cos B. What is cos B? Cos 2y minus sin lambda T1 plus T2 into sin 2y. So this is my first term. Now let me split the expectation, these two terms. So it is half expected value of cos lambda T1 plus T2 into cos 2y minus half into expected value of sin lambda T1 plus T2 into sin y. Now again we know that the random variable is my y term. Apart from that, whatever is present over here is my constant. And we also know that expected value of Ax is nothing but A times expected value of x. So pushing this constant term outside, half cos lambda T1 plus T2 comes outside with expected value of cos 2y. The same thing can be considered for the second term, minus half your sin lambda T1 plus T2 comes outside, giving the expected value of sin 2y. Now what do we know from the prior expressions? We know that C says expected value of cos 2t is 0 and D says expected value of sin 2t is 0. In which case, what happens over here? Our cos 2y becomes 0 and sin 2y becomes 0, which makes the entire of the first term to vanish. Hence, we are just left out with the second term, which is half expected value of cos lambda T1 minus T2. So, what we have in hand is half expected value of cos lambda T1 minus T2. What is our random variable? Y is my random variable. Do you observe any random variable inside this expectation? No, we don't have the presence of y inside it, which means the entire of the term which is present over here is going to be a constant. And now, what do we know about expected value of a constant A? This returns back the constant A. Hence, what we have over here is half into cos lambda T1 minus T2. This directly comes outside the expectation, not affected by any of the process. Now, in the last stage, I can write this as cos lambda. The time difference can be expressed as a function of tau. So we have it as cos lambda tau, which is nothing but a function of tau. Finally, what we have proved is the autocorrelation, which is going to be your Rxx of T1, T2 is a function of tau. Hence, from 1 and 2, what do we prove? From 1, we proved that mean is a constant. From 2, we proved that autocorrelation is a function of tau. So 1 and 2 prove that the random process x of t is a wide sense stationary process. So keep it in mind whenever we need to prove that WSS mean is a constant, autocorrelation function must be a function of tau. If we are able to prove these two quantities, then we are done. It's so easy without any integration. Just by memorizing two formulas for your trigonometric identity, you will be able to complete this problem comfortably. Thank you.